Excellent. Welcome, welcome. Lesson number 4 in our acids and bases unit. Shout out to my homie, Mr. Milks, over at World of Inquiry. I know we're behind you, but we're trying to catch up. So, this lesson is about recognizing acids and bases, so the properties and names of acids and bases. And the first thing we'll start out is with the characteristic properties of acids. These will always, always, always produce hydrogen ions from their formulas. And they react with water to make that H3O plus. So when an acid releases a hydrogen ion, it bumps into a water molecule and it makes an H3O plus ion. That is the nature of an acid, okay? Now, typically, this isn't usually tested in a lab, but they taste tart. Many foods that we eat will contain acids. A lot of the candies we prefer, the drinks that we've got have acids in them to give us that tangy tart taste that we love. Now, they're also going to sting when you get in your eyes and cuts. So if you've ever been chopping up a lemon and you got a little cuts on your fingers, it starts to sting. Or you've been squirted in the eye by like a grapefruit or something like that, that's an acid feeling that you've got. Right? Now, they also react with metals to produce hydrogen gas. And the last lesson of the unit is going to be which acids react with metals to produce hydrogen gas. So all acids will do this. The stronger, the more concentrated, the more vigorously they will react. The weaker, the less, but they would react with metal. And they are electrolytes, so they behave just like salts do when you put the conductivity tester into their solution. The light bulb would light up saying, hey, this liquid here is conducting electricity. There must be positive and negative ions in it. So that's that. This is a test we're going to cover, class rebel, later on in indicators, but litmus paper turns red when it touches an acid. And there's a whole table, K, common acids, with their formulas and names, all right? Now, typically, acids and bases alike look like pure water. You can't tell it's an acid or a base just by looking at it. You got to test it with a pH meter or a pH indicator to see if it's on the acidic or basic side of things, because the acids and the bases react with the water, clear liquid, to produce what they produce, the ions that make the thing compound an acid or a base. Okay. Common bases, there's far fewer, but they all have some certain things in common. They produce the hydroxide ion in solution, either directly, like Arrhenius bases do, or indirectly, like Bronsted-Lowry or the alternate theory of acids bases does, like ammonia. And from the formula in table L, you can see they all have, except for ammonia, an OH in their formula. These would typically be bitter, so think dark chocolate is quite basic, that bitter flavor. Hydroxide ions at play. They react with your skin oils to make things feel slippery. So the base actually reacts with the oil in your skin to produce soap, which is slippery, okay? So that's that. Soaps are basic, so it's part of how they clean oil and greases so well. They react with the oil and grease and carry it away with the water. Again, like acids, bases are electrolytes. So they'll light up a conductivity tester when you test them. Litmus paper is an indicator, and it will turn blue in a base, blue for base, when you're talking about litmus. And again, they look like pure water, so they're clear and colorless again, which is misleading sometimes, but it's always why we test in the lab to make sure we're not just, playing around with dangerous stuff. Bases do not react with metals very well, which is why they're good cleaners. They remove grease and oil stains, but they don't react with the metal. So a lot of oven cleaners and kitchen cleaners for stainless steel are actually quite basic because they'll remove the grease and smudges from our fingerprints, but they're not going to react with the metal underneath. It'd be pretty bad if we tried to clean the stove with a chemical that ate the stove. Kind of defeat the purpose. So let's see. Salts. This is what happens when an acid and a base is mixed. They're always ionic solids. They're product of a neutralization reaction, which is a later lesson. They do not produce acidic or basic solutions, okay? So no ions that are acidic or basic in solution. They do not produce bases in solution either. And so quickly to identify, naming Arrhenius acids and bases, the spectator ion is the root, and all of the acids end with ic acid. So for hydrochloric acid, the chlorine is a spectator ion, etc. Okay. Formulas always have H in them, typically at the beginning. Hydro for hydrogen, chlorine, chloric, and you get the name, hydrochloric acid. Yay! So the formulas are very basic, pun intended. It's very easy to name these things. So for bases, we may name the metal first, and we end it in hydroxide. So sodium hydroxide would be sodium followed by an OH ion. There we go. We got the breakdown. Sodium for Na, hydroxide for OH, sodium hydroxide. That's it. We're done there. So that's the end of the lesson. The next one is strengths of acids and bases. So we're going to go take a tour of the pH scale and what it really means. Thanks for watching. Talk to you later. Click the button and I'll turn off the video.